The heat wave is fading over land, but it continues in the oceans. Yes, we are diving deep this week into the sea. We're going to be talking about marine heat waves, why they're important, and what the impacts can be. Also, did you wake up to an orangey sky this morning? Well, there's a reason for that, and we'll be looking at just how sunny July has been. Welcome along to this week's Met Office Deep Dive. We do this every Tuesday, half an hour or so of delving into a particular subject of meteorology. If you're a Met head or know someone who is, then share the love. Let everyone know that we do this Met Office Deep Dive. As I say, every Tuesday. Ask us anything you like, put any comments you like in the chat. We do try and read as many as possible. And, well, if you haven't done already, you want to subscribe to our channel. Right, who's coming for a dip? I don't like to swim alone, so earlier on, I spoke to an expert. I'm joined now by Dr Ségolène Berthou. Ségolène, thank you for being here. Thank you for joining us on the deep dive. Do you want to explain what your role is here at the Met Office, first of all?
Yes, so I'm an air-sea interaction specialist. My team develops a coupled system between the atmosphere, the ocean, the waves, and also the land and the rivers. So we bring all the forecasting systems together in one research system. So
it's all about how the sea and the air interact with each other. I mean, historically, we've not really done a lot of that linking. They've kind of been kept apart almost, haven't they, the seas and the atmosphere? But obviously, there's a very strong link between the two.
Yes, indeed, and our marine forecast now sends its sea surface temperature into our weather forecast, for example, which is a big improvement from a fixed sea surface temperature throughout the forecast.
So big developments, big changes, and we've seen how important that is, and we've seen, particularly over recent years, how much warmer our seas have become. So that's what we're really talking about today, just the seas around the UK and the sea surface temperatures that we've been seeing. Let's start with what's going on currently. This is the map around the UK showing the sea surface temperature anomaly and how warmer than the average it is.
Yes.
And it's been like that for quite some time. What is the definition? Let's start with, I guess, the definition of what a marine heat wave is, because we know what the land heat wave is. We've seen 3 big heat waves this year across land through the UK. We have to have 3 days over a specific temperature. Marine heat waves measured slightly differently.
Yeah, so it's 5 days.
5 days for a start, okay, yeah.
What the definition is above the 90th percentile of a 30-year distribution. So we've got to be, if we're above that threshold, which should happen about 10% of the time, we're in marine heatwave condition. And if you take that anomaly and double it, triple it, quadruple it, then you're in strong, severe, or extreme. So they're the conditions.
The 4 different categories of marine heat wave, and this was an example of what a heat wave would look like. It wouldn't be in a marine heat wave until you got beyond that 90th percentile, and then it would go through various different stages, perhaps, and then once it's come back down here, assuming that time period is longer than 5 days, yes, and you class that as a marine heat wave. But extreme ones are pretty rare. I mean, that's pretty extreme by the definition. So that is what a marine heat wave is, but it's not based on specific temperatures, and that's because the temperature varies quite a bit in and around the UK. Obviously, it would be hard to put a number on that. So it's based on that 30-year average. Anything in the top 10% would be classed as a heat wave, but getting more extreme depending on how much above the average we are looking at.
Yes.
Okay, so that is what a marine heat wave is. And how long has the UK been experiencing marine heat waves?
So last year we had about 3/4 of the year in marine heatwave conditions. So when you remember, it should be 10%.
It should be 10%. It was 75%. Yeah.
Yeah, even slightly more than 75%. Wow. So 2025 was exceptional. We've had exceptional marine heatwaves in 2022, 3, a bit less in 4. 2025 has been exceptional, and then 2026 is again, yeah.
Let's look at where we're at now. This is the current situation around the UK, and what are the implications? Why do we care? What does it matter? It just makes it warmer if you're going in the sea, right? So what are the implications?
So yes, indeed it does. So you've got warmer seas, that has implication for the weather, and we'll talk later about it, but also has implication for ecosystems. We've had, as you're showing here, we've had actually very few cold spells. The last cold spell we had was 2018.
The last time the sea was below average temperature around the UK?
Below the 10th percentile
Wow, okay.
of the distribution was in 2018, associated with the beast from the east.
Right, wow,
very
that was the last time, okay.
And that means that actually all the winters since then have been above average. And that means that we haven't reached colder sea surface temperatures, and that means the species like the octopus, which their northern limits is more usually southern Brittany, they've been able to migrate north. And it's the first year now in 2026 that we've seen them reproduce in UK waters, and they are in large numbers now in the south of the UK, southwest of the UK.
So there are implications, particularly to ecosystems, around when we have these marine heat waves and when the sea surface temperatures are significantly above the average. There's also implications to the weather, again, as we'll go into more details. But this was quite an interesting, from the heat wave in June, the peak of the heat wave in June. What are we looking at here?
So here we're looking at the sea breezes and how they affect the warmer. So over the sea it's all red because we've run the forecast twice, one with the marine heat wave with the actual conditions, and once we've removed the marine heat wave. And we're comparing the two simulations. So simulations are substantially warmer in the air temperature over the sea. The anomalies are above 1.5 degrees, and then they're carried into the land by the sea breezes. And you can see that sea breeze front really nicely here.
That is really nice, isn't it? It's really striking. That's where the land warms up, the sea doesn't warm up as fast, and you get that circulation. So it's drawing in, and you get that where they clash, which often then can generate clouds and sometimes showers. But this is...
So this is in the afternoon, and this is the cooler phases of the land heat wave. So we had very bad land heat wave in the southwest of the UK, where actually the sea breezes are struggling to develop here because the high pressure is sitting on there.
Right.
But where the sea breeze develop, then the air is, the UK is cooling down by the sea breeze, but it's cooling less than it should because the sea is
so
warmer.
You don't get the same cooling effect. I mean, you still get a breeze off the sea, but you don't get the same cooling effect because the sea is that much warmer than average. Really interesting stuff just to see that. And this is where we're at this year as a whole. So we're going date along the bottom. This is this year's sea surface temperatures around the whole of the UK. Yes. And this is the 30-year average, the dark grey section there. So we see that variation of it. Interesting that the sea surface temperatures bottom out kind of the middle of March and peak late August into September. So there's that lag with the sea. So you always get that kind of variation through the years. And what are each of these squiggly lines are every year for the past, since 82, is it?
Yes.
Yeah. And then this is the current year, and anything red shaded in there is above that 10th percentile, above the 90th percentile. So we can see quite clearly here those three peaks that we've seen. So heat wave 1, end of May, across the land, but also in the sea, and then another one in June, and then the current one, or one that's kind of ending now, certainly over land, but still with that heat. So we can quite clearly see those three peaks, but also even through the springtime, temperatures were significantly above average, and still with that heat wave. So really quite remarkable to see that ongoing situation that we have at the moment. Let's look a little bit about the seas around the UK, because they're quite interesting. This was quite interesting. I did this experiment on Aidan and Alex Burko yesterday. I asked them how many Eiffel Towers you could fit into the depth of the North Sea at its deepest. And I think one of them guessed about 26 and the other one guessed about 20. But it's actually remarkably shallow, the North Sea, isn't it? Which is really significant for things that we're seeing.
Yes. Indeed, yeah.
So what have we got here?
So this is the bathymetry around the UK.
What does bathymetry mean?
It's the depth of the ocean.
The depth of the ocean. Where does that come from? Is that some kind of Latin term? I've never seen that. But bathymetry. That's a good one for a quiz. The bathymetry of the UK.
So yeah, that's showing, and everything in grey colour here is shallower than 250 metres, and the Eiffel Tower is 300 metres high. So if you dip the Eiffel Tower anywhere here, it will stick
you
out.
would still see the top of the Eiffel Tower pretty much anywhere within the North Sea. It does get a bit deeper as you get right towards Norway, doesn't it?
Yeah,
There's
that's
a
the
bit of
Norwegian
there.
trench.
Yeah, but most places in and around the UK, the seas are not as deep as the Eiffel Tower is tall, and really quite shallow. So that point there is represented here.
Yeah, that's the English Channel, so that's the Dover Straits here, where the Eurotunnel goes through, and it's only about 30 metres deep here. I mean, the Dogger Bank is even shallower than this, and then you've got the North Sea here that goes a bit deeper.
So kind of a midpoint, if you like, in the North Sea is around about a third. Well, not even a third, is it? It's less than a third of the full depth of the Eiffel Tower. That is. Yeah. It's really quite remarkable, but it has an impact, right? It's really important. That being so shallow is really important for what we see weather-wise, but also particularly with marine heat and retention of the temperature. Yeah,
exactly. So in around the UK, basically, we also the bit that are shallower here are insulated by a current that goes around that shelf, and the life of water in the Northeast Atlantic is relatively independent from what happens on the shelf.
Let's show you that, because that's kind of displayed here, right? So what are we looking at here?
Yeah, so here we're looking at surface currents over a 25-hour period, and this is the currents that are driven by the tides. So around the UK, when the tides come up at 12.4 hour frequency, they drive big blobs of high and low sea level, which propagate around the UK. And this means that the water has to move around. The UK coastline is quite constrained between all the land masses, and every 6 hours the current direction changes. And that current is much stronger than what happens in the Northeast Atlantic.
It's basically looking at the speed of the sea is moving at here. So there's really fast-moving seas in and around this part.
Exactly, but it moves one direction and then comes back. So it kind of is in and out. Is moving, and that means that all the seas around here, they're shallow, they have strong currents. They actually are fully mixed throughout their depth. So we can't develop a warm layer at the surface in these seas. So these seas, just very close to the UK, take longer to warm and longer to cool. So they store that heat. And it also means that the heat that is trapped in the Northwest European shelf struggles to escape from this shelf.
Right.
Because there's no depth. There's no depth into which the heat can sink, and therefore these areas, especially the southern North Sea, has been warming at twice the rate, so at about 0.5, 0.6 degrees per decade, whereas the whole average is 0.3 degree per decade. So these regions have warmed in the last 40 years faster than other regions, because the heat is trapped there.
It can't move. You can't. So basically, when you heat the sea, the sun beats down, and obviously, but that only heats the top. It's not. And you get some circulation, so some of it will go down, unlike the land where it can't go down, obviously. So you have that circulation, so that's why it's a different mechanism. Yes. But the speed at which everything's moving is really important to how that heat gets transferred around. So you get these big variations, because there's very little movement there in the North Sea, and as we've seen, it's also very shallow, whereas around here it's still very shallow, but you're getting that movement. So it's different mechanisms creating different temperature profiles at any one time, and it varies quite a lot. And you've got these little. That's quite interesting. You pointed out there's little eddies earlier in the ocean, but you don't get those in the North Sea because you haven't got the depth.
Yes.
So there's all these very subtle shifts and all these very subtle things that we need to be aware of. People just think, oh, I'm getting to sea. They may wonder whether the tide's in or out, but there's actually an awful lot going on, and the way that it gets heated, the way it's really fascinating, the way the heat gets transferred and moved around.
Yeah, and when it's high tide in Cornwall, it's low tide.
Yeah, that's another thing. People don't realise that, do they? They just think, oh, it's high tide, it must be everywhere around this. Yes. The differences that you see similar maps to this with the way the tides change in and out around the UK, and it's all very different, all very complicated. All thanks to the moon, of course. So yeah, really interesting the way that everything shifts around and can change. Let's look now at historically what we've seen in the past, and go back to 2023. We'll talk about Storm Babet in a minute, because that's what your paper is all about. That's out today. We'll have more on that in a second. But before we get to the heat in the sea in the autumn time, 2023 was remarkable for this bulge. So this is the same graphic we saw earlier for this year, but this is for 2023. So we've got the whole year, and this was particularly strong marine heat wave. So these are the sea surface temperatures around the UK, and we had a huge bulge there in June into July. That was one of the biggest heat waves we've seen, marine heat waves we've seen around the UK.
Indeed, yeah.
And what we've seen from that, actually, we can see the impacts from that generated. We've talked about the sea breezes, but actually they can then generate, increase the shower activity. And that's another study that's been done, how the marine heat wave enhanced heavy showers during the summer. So this is from June 2023, and it shows how the storms were enhanced. If we zoom in on the radar first of all. So this is the radar from a specific day. What are we looking at here?
So we're seeing a band of rain here. It's centred in the middle of the southwest peninsula, which corresponds to that sea breeze convergence, sea breeze coming from the north, so south converging, triggering ascent and then triggering convection. And we see also some bands of rain here in Wales in the Midlands, and some convection going on.
This was a day in the summer where the heat was causing showers, but that classic where the winds are combining, they're converging, pushing the air, the air can't go down, so it goes up, creates showers. But what you've done there's been some research done. Was it you involved in this, or was it this is your paper as well? And what are we looking at here? What have you compared?
So we run the weather forecast as it is set up now, with the sea surface temperature coming from the marine forecast, which is quite accurate. And this is showing you the probability of rainfall across an ensemble, because showers are a bit chaotic. So
chaotic, good word.
We get these bands here that well captured by the model, where we had the bands in the reality. And then we reran the same forecast, but removing the marine heatwave anomaly.
Right. And
we ran the forecast again. And what you see is that the probability of rainfall really decreases dramatically without the marine heatwave. So we can quite confidently say that this convection that we had that day was probably triggered and enhanced by the marine heatwave and that sea breeze dynamics.
So proof there. This is the forecast, and that's pretty much what happened. You took out the marine heatwave, and the signal was much less for that convection. So from this, you can deduce that the convection was heavier, more intense thunderstorms as a direct result of the marine heat wave. So it's another one of those impacts. We've talked about the ecosystem, but along with the sea breeze, not cooling down the UK as much, and this is another one of those impacts that you can directly see as a result of the sea being hotter than it should be. Really interesting stuff about what happened in the early part of June that year, but then something more significant, well, no, maybe not more significant, but something very significant happened later on. And that's what your paper is about today. The paper's published today, all about this, which is Storm Babet, October. This is from the 17th, I think, the 17th of October. So this is the storm. We named it a couple of days ahead of time. There's Spain and Portugal, and there's the Iberian Peninsula. The UK's here, and this is the storm as it approached the UK. Came up, it's coming up, it's bringing up a lot of warmth, bringing up a lot of moisture, because it's crossing the Bay of Biscay and coming up from the south. So it brought warmth, it brought moisture, and it brought a lot of heavy rain, and caused quite widespread problems across eastern Scotland in particular, but also other parts of the UK were pretty badly affected. We were obviously making videos about it, Aidan highlighting that risk area, and this was what the warnings board looked like Thursday to Saturday. There was a lot of warnings in place from this storm. Wind was a bit of an impact, but it was more the rainfall, wasn't it? And the wind had an impact more because of the direction rather than the intensity of it. So we had a lot of warnings out, including red rainfall warnings. We were expecting 150, perhaps 200 millimetres of rain over the hills of eastern Scotland. That's pretty much what we saw. but that was all enhanced by the fact that the sea was warmer than average. So what have we got here? These are in your paper today, aren't they? So what are we looking at here?
Yes, so this paper is in collaboration with the University of Reading. PhD student Pierre Goswami is a lead author. And this is the map average over the 3 days of Storm Babet, which shows, in general, low pressure, as you've described here. We also had a higher pressure over Scandinavia, and that jet here is squeezed between that lower pressure, which couldn't progress because of the high pressure, and so we've got that jet, that is low-level jet, strongly flowing from Denmark into Scotland. And you did say, and it's right, that it did bring some warm and moist air, but on the first day of the storm, but on the second and third day, that air came from Scandinavia. It was very cold, very dry, and it arrived on top of this very warm sea. So the sea was about 1 degree warmer than usual, which can seem not much, but actually that heat is not just at the top here. We've seen it being throughout the depth of
should we
the
go
North
back to
Sea.
let's go back to this one, because you talking about this is really interesting. So this is, again, back to 2023, the sea surface temperatures. That was the one we talked about earlier with the incredible heat in June, but this is the build-up to Babet. So Babet happens here. What happened in September?
Yeah, so Babet killed the marine heatwave, more or less.
That's interesting, and that's because it mixed it up.
It mixed it, and it took a lot of heat and evaporation out of it. And the most of the cooling just happened by evaporation and heat transfer.
Yeah.
And what happened here is that we just had, again, anomalously anticyclonic conditions, very sunny, very weak winds, and that anomaly built. It's quite strong, really strong. But it built at the surface, and then as you go into September, October, where you've got a little bit more mixing going on, a bit more winds, that anomaly is sinking throughout depth, and it's not disappearing from the system. The heat is just being transferred across the whole column, and it's a very important preconditioning for Babet, because what the storm didn't have to do any mixing. It just was all mixed throughout the column, and it just took the heat and the evaporation out of that.
So high pressure dominating, a lot of sun beating down, the sea surface temperature peaked.
Yes.
But then this isn't necessarily, that's not the sea cooling down, it's just it mixing through. So the whole of the North Sea, which as we've seen isn't very deep, got warm. So there's so much energy just all trapped in, not just in the surface, but in this. So when Babet tried to mix it up, it was just, there was still a lot of energy there. There was a lot of energy there because of that. Okay, that's really, really set the scene for what Babet happened. There's that storm coming up. This will then show the, let's go through this again. And then we had that easterly wind that persisted for a number of days. Unusual wind direction in the first place, drawing in all that warmth. So this is the sea surface temperatures being above average, but as we've seen, the depth of the North Sea was unusually high, so right the way through, all bringing that energy. And the result was pretty remarkable in terms of the impacts that we saw. What are we looking at here?
So here what we've taken is we've taken our coupled system, air, atmosphere, land, with rivers, ocean and waves, all coupled together, and we've run the forecast, and the forecast is in red here. This is for the river South Esk and Flow, which both of them burst their banks, and this is the surge part, of the sea level, and this is the wave power. So the coastal damages brought by Storm Babet were quite incredible. The equivalent of 5 years of erosion happened on the east coast of Scotland.
5 years worth of erosion happened just in 3 days from the storm.
Yes,
wow.
And it's a combination of very high river flows and long lasting. This is 1 day of wave power, which is really high. And so what we've done is that we reran that system, but instead of initializing our ocean in 2023, we initialized it 1 year that didn't have a marine heatwave in. So we reran the storm as if it was the ocean conditions of 2020. And then we've looked at this blue is without the marine heatwave, this red is with it. And we see that across all the hazards we've increased between 9%, we've increased the wave power by 9%, we've increased the river flows by 12 to 18%, and the surge by about 20%. And these are several factors for that. Obviously, we know that's quite a well-known phenomena that, as we discussed, when the sea is warmer, it brings more moisture into the atmosphere and it rains more, and therefore the river flows are enhanced. But this can be non-linear. The soil moisture was already quite high, so the river flow is enhanced more than the rainfall. And then we have the coastal impacts, which are linked with, we had that very cold, low-level jet that went over the really warm North Sea, and that brings a lot of convection in the boundary layer. And the winds that are really high aloft are brought to the surface. And as the sea is warmer, that boundary layer is higher, there's more wind brought to the surface, and the waves integrate how much more wind you have. The surge also integrates how much more water you push towards the coastline. And this led to small changes in the sea, small changes in the atmosphere, but then integrating this into bigger, double-digit hazard
big impacts.
Changes.
So even though those winds after the storm were effectively cold, because they were coming over that incredibly warm sea, like you said, it created a bigger circulation, you got more convection, more uplift, it then generates a bigger self-perpetuating almost, coming back again, stronger winds, all adds to bigger waves, and the blue here is without the heat wave. So you've been able to do the research, run the computer models without the heat wave to make that comparison, and all the aspects are showing that increase of anything between 9 and 20%, depending on obviously more river flow, increases more flooding, and obviously more wave power, as we saw increase the coastal erosion. 5 years worth of damage in just 3 days. Remarkable. There's lots more in the book. Try and put the link to the paper actually in the description. But there's more on the Met Office website today because that paper is fresh out. Who is it with? It was with Reading University.
Yes. Yeah.
Excellent. So that's absolutely fascinating. We've seen that why marine heat waves need to be monitored, why they're so important, because the impacts that they can have. Really fascinating. The
particularity of the northwest shelf is also that lack of depth. So when that storm comes, if it had come over the Atlantic, it would have mixed some colder water in, and kind of get rid of the anomaly. But here there is nowhere where this anomaly can go apart from into the storm. Into the storm,
and that because of the track and the way that easterly wave was generated, the easterly winds were generated. Really fascinating. So it doesn't happen with every storm that we see coming across the Atlantic, far from it. There's the particularities for Babet, but why? Really important to be able to understand that the differences that those marine heat waves make, or the temperatures in the sea. Really fascinating stuff. So one more question, I guess, then what does the future hold? We know that the climate is warming. We know that we're expecting temperatures to rise as well. Hopefully this will play. We can show another graph. It seems to have frozen on me. Never mind. And we're back. It's working again now. So just to end on, what are we looking at here? Future projections.
Yeah, so the red line here is that 2023 marine heat wave that we've seen was very intense. But when you put it in the climate projections, the projection is probably one of the worst case scenarios we can have, but it's middle of the century. This anomaly, instead of being that big anomaly, could just be a small warm anomaly, almost near the average.
Okay.
So gradually that baseline, that average will shift up, and if you take a fixed baseline, it means more marine heatwave days, as we're seeing already.
So they're the projections there in the yellowy gold, and you actually see a bigger gap through the peak. So the summer peak is the difference in the future is larger than the differences through the winter and the spring.
Yes, indeed, and this is because the seas, as we discussed, some parts of the seas around the UK stratify, so you've got that warmer layer of water that happens in the summer, and therefore it's easier to warm. So more surface forcing means warmer in the summer, whereas in the winter you've got to warm the whole depth, which takes longer to warm.
Longer.
Yeah, and also it shifts a bit towards the autumn because that stratification in these projections actually lengthens by about a month. So we have a month or more of stratified seas with that warmer layer at the
and
surface.
Potentially the implication, I guess, on our storm season, traditionally October, November, we often start to see those intense lows.
Yes.
So that has an impact perhaps on those with warmer seas, as we've seen. Really fascinating stuff. Ségolène, thank you so much for being on this week's deep dive. We'll have you back again. But yeah, fascinating paper, and thank you for explaining marine heat waves to us.
Thank you.
Absolutely fascinating to chat to Ségolène earlier on. Right, quick look at the weather. Not going to go into too much detail. Obviously, there'll be plenty more in the 10-day trend tomorrow with Alex Burkill. But we are still pretty warm across the south at the moment, but signs of things cooling off a little bit as we go over the next few days. So that by Saturday, still some warmth across the southeast, but we are seeing temperatures dipping away. A lot of people after some rain. Any sign of that? Well, we are seeing a shift in the jet stream. It's been pushing up to the north, allowing this chunky area of high pressure. But if we go through the next few days, what happens? The jet stream just gets a little bit about it and starts to drift south. As a result, the high pressure gets squished to the south, and we start to see weather fronts, low pressure systems influencing our weather a little bit. Initially, some showery rain over Scotland and Northern Ireland. As we go into the weekends, well, that jet is just trickling a little further south and generating a little bit more in the way of cloud and showery rain coming in. Now, nothing for gardeners, growers to get too excited about, but we are in for a more changeable outlook as we head through the weekend into the early part of next week. And yes, most of us will see some rain. Most of us won't see very much, but at least there will be a little bit coming in as these weather fronts move through and the jet stream has sunk further south. High pressure isn't too far away, however. So, as I said, more on that in the 10-day trend tomorrow. But a couple of other things I wanted to draw your attention to that we've seen. Really quite interesting satellite image from Tuesday morning. You can see the high pressures out here. So there's quite a lot of cloud trapped under the high. And around it, the breeze coming in from the north. So you can see all the cloud filtering its way in. But just in here, notice the hazier scene. So you may well have woken up this morning over parts of Wales and the Midlands to quite a hazy, murky, almost orangey sky with the sun rising here because of wildfire smoke. It's quite high up, so it's not being generated across the UK. This is likely to have come from somewhere across North America. A lot of wildfires still burning there. It's hard to track it down if you go back through trajectory, hard to actually pinpoint where it came from, but it looks like it's come from North America somewhere over the recent weeks, and yeah, quite a bit of it trapped there across parts of the UK this morning. So you may well have noticed a slightly more orangey hue to the sun. Speaking of sun, we have seen a lot of it in July. Yeah, no joke, Alex. This is the latest sunshine chart up to the 20th of July. So for the first 2/3 of the month. Normally by this stage, we would have expected to see about 65%. So that would be the average. Most places are already above that. In fact, everywhere is above that, 65%, except perhaps Shetland, Orkney there is perhaps in that 30 to 50% bracket. No, the 50 to 70% bracket. Most of the eastern side of Scotland, northeast England in the 70 to 90%. So even that is above the average. But all these yellow areas have already seen their July average of sunshine, still with 1/3 to go. And pockets of Wales there, North Devon, Somerset, have seen between 130 and 150% of their July sunshine. Already, we've had more sunshine than we had in the whole of July last year. In fact, this is the sunniest July since 2021. Aidan did some statistical analysis on this. So yeah, really quite interesting how much sunshine we've already seen so far this July. It's been a remarkable summer, and we'll have plenty more on the summer stats, no doubt, as we go through. But yeah, just highlighting there how sunny July has been. Right, that is pretty much it from me for this week's Met Office Deep Dive. Again, big thank you to Ségolène for being on. Let us know in the comments if you like that kind of stuff, if you like it when we get the experts in. Let us know in the comments if you've got any other questions about the weather or about climate. We do try and go through them. Sometimes we answer them on the Weather Studio Live on Friday. That'll be me and Alex Burkle, I think, this Friday. So that's the Weather Studio Live at 12:15. Make sure you subscribe to our YouTube channel and then you won't miss one. And if you can hit that thumbs up button for me, that would be brilliant. Thank you very much for watching. I'll see you again soon.